Good afternoon, everyone. Can you hear me okay?
Yes, Professor.
All right, great. Any questions on anything before we start the material? Any homework questions or anything on any previous sections, 1.8, 1.9?
I have a question.
Sure, go right ahead.
Okay, so it's on 1.8 and it's question 57.
1.8.57. Let me see what that says. 1.8. $57. All right, let me see if I can. That says you're looking for the inverse. And make sure I've got the right one here. We want the inverse of G evaluated at 10. Is that the right one?
Yes, it is.
And G, they give you a table. So G evaluated at 10. So when we say G evaluated at 10, what variable is this value right here?
That's going to be the X, right?
That's going to be X. That's correct. Okay, so if we look at that table for G and set X equal to 10, all right, so we get, what do we see when we get that? G evaluated X, and we want the inverse. So if G evaluated at 10 is what?
-1.
-1, okay. So that says inverse -1. That makes sense. And then the inverse of F evaluated at -1 is going to be what? At -1.
Would it be 2?
Correct. Correct. So the inverse of F evaluated at -1, that shows us this value here. So we're going to get X equals 2, aren't we? So it looks like F evaluated at 2 is -1. And if we back up, F, the inverse evaluated at -1 is 2. And then that's this. So it looks like we should get 2 and -1. Does that make sense?
I think so, yeah.
Okay. Do we have any other questions on any homework problems on 1.7 or 1.8? Go right ahead. We're looking at 1.8 or 1.9. Anything from 1.8 or 1.9? Or can we just go right into today's material? Okay, I'll take that as a no. Good. And so let me get today's material, which talks about 110. Now 110, we're going to be talking about modeling with functions. So when we're modeling with functions, let's take a look at what we might want to, some of the things we might want to do. So some of the objectives, let me just maybe bring this down a little bit here. So some of the objectives, then we want to be able to, construct functions from a verbal description. Those are word problems, aren't they? And everybody likes word problems because they relate to real world situations. So that's good. So we want to give a verbal description, and we might also want to be able to construct functions. From maybe if we're given a formula. Okay. So that's the kind of thing we want to be able to do. And many real world problems involve constructing mathematical models that are functions. And so in constructing these functions, you need to be able to translate a verbal description into some sort of a mathematical representation. In the mathematical representation, we end up a math representation. We might want to call that a mathematical model. Okay. So let's just see if we can take a look at some examples. If you're asked to choose between two plans, for, let's say it's for texting. And you might have the first plan, which has a cost, I'll say C for plan A. The cost for plan A might be some monthly amount, might be some dollars per month, maybe it's $15 or $20 or $33 or whatever the monthly fee is. Plus, you might be charged per text message, maybe not per character in the text message, but just for the text message itself. And maybe you're charged, maybe it's 8 cents per text message. And so that's the first plan. And there might be a second plan. There may be several plans, but let's say we have plan B. Cost of B, maybe that's could be higher, could be lower, and we might call this the fixed cost, and this the variable cost. So we're asked to choose maybe a plan where we're given a fixed cost and a variable cost. And over here, we might have a plan B with a cost less or more. Maybe if it's less, maybe it's $3 per month. And but it has a steeper variable cost. Maybe the variable rate is maybe it's 12 cents per text message. So again, here's the fixed and here's the variable. And you might be asked, you're sitting in a meeting with your boss and your boss says, well, you've been through Math 141 over there at Bellevue College, and I know they have some example problems that they take you through. They have you calculate fixed variable costs, and we need to figure out which one we're going to go with. So if you were given these two plans, you might say, well, there's a couple of ways we could determine which is the best plan for us. We might plot, and maybe we plot maybe text messages along the horizontal axis, and maybe we count dollars on the vertical axis. And I don't know, maybe we're at 10, 20, 30, $40. And so if we were to plot what these two plans look like, we might say, well, let's see, well, I'd probably better put something across the bottom here. And we're up to, well, we don't know how many messages or how many text messages. So let's just take some guesses here. Let's say we go put some hash marks out here, and let's say we go 100 text messages, and this is going to be this is just the number of text messages that we do, and maybe we have 200, maybe we have 300, maybe we have 400. Who knows how many we have? And maybe I should kind of make this a little more of a hash, or I can plot some values here. Okay, so let's say I've got sort of a table that looks like this. And if I were to plot these, if I plot plan A, let's see, that's a fixed cost of $15 a month. So I'll say that's approximately here. So plan A starts, even if you have no text messages that you send during the month, it's still going to cost you $15 just to be on the plan. And then if you start sending messages, it goes up at $8 or 8 cents a message. So let's see, if I'm out here at 400, let's see what that ends up. 400 times 0.08, and that looks like that's 32. Is that right? 400 times 0.08. So $15, 0.08 is 32. So here's 35. So let's say here's 32. And this is it is linear, isn't it? It's a straight line. So let me get out a straight edge here and see if we can create sort of a straight line here between those 2 points. And let's just say it looks sort of like that. And that's plan A. So I could label that plan A, and plan B starts down here at $3 a month. So there's 543. So maybe it starts down here, but goes up at a steeper rate. So at 400 times 0.12 is 48. So 10, 20, 30, 40. Here's 50. So let's say 48's here. There's 48. So if I were to draw a line here.
Or do you not need to?
Is there a question there? Go ahead, give me a question.
I was asking if for the 400, sorry, text messages, would you need to add the 15 and the 3 for each plan because that's the monthly cost, or would you
You're right. You're right. I'd have to add it to this. Let me see. Do I want to redo that? Well, maybe we should. Maybe we should. That won't be too hard to fix, because that is the variable amount. So let's say if I go 0.08 was 32 plus 15, 47. So let's say we go 15 is here, plus 8, 32, 47. So 40. Let's say that's 47 there. Okay. That look better to you? We do it that way?
Yeah, thank you.
Okay. And for the other one, starting at 3 and 12 is 48 plus 3 is 51. So there's 51. So let's say it's there. The idea is going to be the same. The physical number is going to be different, but the idea, the concept is the same. Okay, so we have plan A starting at 15, plan B down here, and maybe I should color code that so we can see it a little better. Maybe here's plan A. And I call this blue plan B. And the idea that we're trying to come up with is which plan is going to be better for us. So your boss calls you in and says, you know, we've got these two different plans here. And one is at 15 a month and 8 cents a text. And one is at 3 a month, but a steeper rate for the text. And your boss says to you, you know, which one with? What do you think? Which one should we go with? We have, or does it make a difference? Maybe I'm making a wild assumption here that it makes a difference. Maybe in the end, in the final analysis, maybe it really doesn't make any difference. Or
It's all
does it?
based on how many texts you and your boss plan on sending, really. So
All right,
if you
so
pass
you're-
a certain amount, one plan will be better than the other.
So you're saying the answer to that question is it depends.
It's on the intersection is where you're going to find the answer, right? I mean, that's what we're looking for, right? Is that intersection, which looks to be roughly 280, 260
Well, are we
text-
looking for the intersection? Your boss simply said, which is the best plan? And you're sitting at the table and you say, well, sir or ma'am, it depends. And then your boss comes back and says, well, it depends on what?
You ask them how many texts they're going to send a month on average.
Okay, so then it depends on the number of text messages that we're going to send. Everybody agree with that? Anybody
Yeah.
disagree? Okay. All right, so if we say, hey, it's going to depend on the number of text messages. Okay, and so your boss might come back and say, well, okay, well, if I'm going to send 200 text messages a month, which plan do I want to be on?
You're going to want to be on plan B.
All right, Christopher, thank you. Let's get some new volunteers. Let's have everybody have some fun. So if we send 175 text messages a month, which plan do we want to be on, new volunteer?
How many texts did you say?
175.
B.
B. Okay, so anywhere down in here, if we're below whatever this value is here, which we can calculate, but looks like we could call that the break-even point, couldn't we? Where at that point, it wouldn't make any difference which plan we're on. But if we find out that the number of text messages we send is down in here, we probably want to be on plan B. And if we're above that amount, we want to be on plan A. Does that make sense to everybody? So if I were to say in green, I want to be either there or there. Would everybody agree with that? Anybody disagree with that or not?
Are you
see what
sure
we're
again
talking-
how you were able to graph it? 'Cause I
Yes.
understand the starting point at like 15 and 3, but I don't understand how else you got to graph it.
All right, maybe I graphed it wrong. Let's see what we did here. So I have two functions, function A and function B. And these functions, let's pretend like I don't give you a paragraph of what we're talking about. I just give you two functions and I say, here's function F of T for text message. And I say that that function is 0.08 T plus 15. And this is in dollars and this is dollars per month. And if I gave you that function, could you graph that function? Does this look like
Yeah.
this look like it might be a line that says y equals mx plus
Yeah.
b? Okay, where M would be this value here, the slope. And the y-intercept would be 15. That makes sense?
Yeah, that makes sense so far.
And then if I gave you function G, different function, still based on text messages, T equals, and I said, well, that's going to be 0.12 T plus 3. Now, does this G function have a steeper or an increased slope or a less of a slope than F?
Does it have more of a slope since it's higher?
This has a larger slope, doesn't it? This is M
Yeah.
right here. But the y-intercept, is the y-intercept greater or less than?
Y-intercept's less than.
Less than, okay. So if we were to plot these two, and we were to plot, now I've said, if this one is the, I said that's cost B, and I said that was cost A. And I go back to the way I plotted them here. These are those two functions. One is $15 a month and 8 cents a text message. The 15 was the y-intercept, wasn't it? So I said, here's 15, here's the y-intercept. And it goes up at a rate of 0.08. That's the slope. Here's the value here, going up at 0.08. And I went out here 400 times 0.08 and added it to this 15, and I got 51 out here. I got 47 out here. So I went up at this rate here. That makes sense?
Kind of, because like when I did like 0.08 times like 100, for example, to get that point, I got 8. Is that right? Or is it not right so far?
Well, 0.08 times 100, if we have 100 text messages,
Yeah.
then we would be down in here, wouldn't we?
It's gonna put me at 8. That's why I was confused. Because 8's below. So
All right, but we have to add that to the 15, don't we?
oh my god.
So this is the fixed amount, fixed cost, and this is the variable cost. It's variable because it depends on the number of text messages. So if I had 100, I'd go over 8, right? 0.08
Yeah.
times 100 is 8. Add that to the 15. Okay,
I
and I would
understand.
get,
Yeah, I
and
forgot to add the 15.
okay, yeah, no problem. So then we'd get that to be 23.
Okay,
All
yeah,
right.
that makes sense now.
All right,
Thank you.
makes sense? Okay, sure. Other questions at all on what we're doing here? We want to make sure we understand the principle here. This is cost equals fixed cost plus variable cost. And many of your cost functions look like that. They're a straight line, but they're fixed and variable cost. Now, some cost lines may not be. They may not be straight lines. They may be curved lines. Okay. So for this particular problem, we're just asked to choose between two text plans where the functions in fact are straight lines. And so this pink line here represents beginning at 15. So I'll call that plan A. And then plan B was the starting at 3. So that was this one down here. And then the green line represents where we want to be. We want to be on the lower line because the lower line represents the lower cost, doesn't it? Because as we go higher, we're getting higher costs. As we go out this direction, we have more text messages. And so if we go out here to 400 or 300, 200, whatever, we can plot how many, what the dollars per month is going to cost us, which is the sum of the fixed and the variable costs. Okay. Everybody okay on that? So now, if you have questions, just ask them. So now the idea is we want to find out, well, what is that break-even point? I'm going to call this point right here the break-even point. Can we calculate that? Do we have enough information to calculate that? And if so, let's calculate it. So first we want to determine whether we can determine it or not. We think we have enough information or not?
Can we set the equations equal to one another?
We
And then
can.
solve for X- or for T?
We can. Let's do it. 15 plus 0.08 T equals 3 plus 0.12 t. So now we've set, if I said this is cost A as a function of t,
Professor, I can't see your paper.
and this is cost B as a function of t. Okay. So are we able to solve, forget about the above problem, forget about the discussion we had, just if you were given this problem, this just a straight algebra problem, could you solve that? And if so, let's solve it. So let's take a minute or two. It's 3:23 roughly. Let's go ahead and solve that and see what we get. And just open your mic. And hopefully we'll have some new volunteers participating. We don't want just one or two people having all the fun. Is this 0.04 t? Where t equals 12 over 0.04. 12 divided by 0.04 is 300. Is that what you guys get? Is my arithmetic correct here?
Yeah, I got the same thing.
Okay. And what is this t? What are the units of this 300? What is that? What is that? Apples or pounds or cubic centimeters? Or what is that 300?
Text messages.
Text messages. Okay, so if we were to go look at our graph here, it looks like this value, this rough curve here must not be very good because it looks like they're coming together over here at 300, not over here. Okay, so I'm going to label this point here where they come together, 300. And then how about the vertical value? What would that be?
Can't we just plug in 300 into any of the equations?
All right, go ahead and do that.
So no one has an answer yet?
No one has answered yet that I've heard.
I mean,
39.
39
Yeah,
and 39 what?
dollars.
$39. every year?
No, just for 300.
It'd be $39 every year or every week or every day or every what?
For every 300 text message.
Per every 300 text
Per
messages?
month, if you send per month, if you send 300 text messages.
If you send 300 text messages a month, your charge will be $39 in that month. That makes sense to everybody? Questions on that?
Wait, so
All right.
how'd you find $39 again?
All right, how do we find $39? Give me a volunteer that can tell me how I found $39.
Well, I plugged in 300 for 0.08 since we found out the text messages, so I just plugged in that for the top equation.
So you use this equation here?
No, I used it with 15 plus 0.08t equals 3 plus 0.12t.
Is that this one?
No, it's the one below that.
This one?
No, below.
So the answer is you can plug it into either one of those. You don't need to plug it into one equation equal to the other. Okay, you can plug it in for t on either side.
Sure, you can plug it in here, can't you? If 300 is the number of text messages, if we put 300 here and times it by 0.08 and add 15, then we'll solve this function. Right? Well, if we put that in our calculator, it would look like this, wouldn't it? 15 plus 0.08 times the number of text messages, if it's 300, then we would get 39. All right. Now we could also use our TI-84 to calculate this, couldn't we? Let's say that we put in Y1 in our TI-84 as a 15 plus 0.08x, which is this equation here. And we have the second equation is 3 plus 0.12. So we have both of our equations in. And then we need to set up a window. And we said, well, let's see, we're going to have text messages that might go from 0 to 400. And this says that the X value, the text messages are the independent variable. What we're saying is the monthly cost depends on the number of text messages. And the Y value being the monthly cost. And if I say that's minimum of 0 and a maximum of 50. So I've set up my window. I've set up my two equations. And when I graph it, I get a graph that sort of looks like that. And we say, well, that's nice, but I need to find a value here in 10, 20, 30, 40, 50, or 100, 200, 300, or whatever the values are that we're looking at here. So if I do a second and a calculate and ask for the intersect 5, then the calculator is going to come back and say, well, is this the first curve? And I can say yes and hit enter. And is the second curve? Yes. And I can say and hit enter. And you want me to make a guess? Yes, I will. And it says, well, they intersect at 300 in the X direction. So we're going out 300 here. And the Y direction is 39. So we have a point out here at 339. So if it looked, now let's see if it looked, well, I did it over here. So it's out here 300 and it's up at 39. So let's just highlight that so we can see it a little better. So this point here, which is right along here at 300, and then we're saying this point here is at 39, which is that point there. Now, I'm not as concerned with how pretty your graph is, but rather you've labeled points that are real points, saying that, well, this point here, I can't really tell where it is by looking at the graph, but that's okay, because I can look at the note here and say this point is at 339, 300 comma 39, okay. And 300 would indicate the number of text messages and 39 would indicate dollars per month.
Could you please show again how you found the intersection on the calculator?
Yes. Yes, I put in the two equations. We okay on that?
Oh, yeah.
And then I set up a window that would allow me to show where the intersection is. I had to know about where my values were, and I went out here to 400 in the X direction and up to 40 or 50 up to 50 in the Y direction. And then when I hit graph, I get these two lines. So those are the two functions, plan A and plan B down here. And so then if I want to find the intersection, I hit second and calc, which is there, and I get this screen. And on this screen, it says, if you want to find the intersection of those two lines, go to 5. So I hit 5 and it says, where's the first curve? And I move the cursor down here on the blue line and I say, yes, that's the first curve, and I hit enter. And the calculator comes back and says, is this the second curve? And I hit enter to say yes. And then I hit enter a third time and the calculator says, well, if those are the two lines, then that's the intersection of those two lines. And they intersect on the x-axis at 300, which is shown here, and on the y-axis at 39. So this point is 300, 39, which is this point here on my roughed out graph here. Here's how it actually looks, but here's how it is in my rough graph. And this rough graph is fine as long as I label my point. And I want to emphasize that anytime you're showing me a graph with your work and you've got points on your graph, be sure you tell me where those points are.
Okay, thank you.
Sure. Other questions on that one at all? Okay. Let's go ahead and take another example then. Let's say, this is kind of an interesting one. Let's say we run an airline. And our airline carries 8,000 passengers. Per month. We say, hey, that's great. And then each passenger pays, let's say $100. So that's pretty good. I got myself a going concern here. This is great. I just have to keep the passenger rate up, and I charge them $100, and I get a pretty good rate of return here. But it turns out I've done a little market research here, and it turns out that for each $1 increase in the ticket price, the airline will lose 100 passengers. So he's saying, well, there's a little connection here between the price. I may want to raise my price and make a little more money, right? We always end up saying, well, we've had inflation, or my costs have gone up, or whatever the issue is, and I need to raise my prices. But you have found out that if you raise your prices for each dollar increase, you're going to lose 100 passengers. You're either going to go on some other airline, or they're going to decide not to fly, or they're going to fly less often, or whatever the issue is. So your boss comes to you and said, hey, you've been through all these courses and you've taken all this stuff. What I want to know is, I want to know the number of passengers. So let's say I want you to find the number of passengers as a function of the ticket price. All right. Now maybe if I call the ticket price X, we don't know what the ticket price is. But I want to know the number of passengers that are going to be flying on my airline per month as a function of X, the ticket price. And right now I'm flying 8,000 per month. So I can say, well, hey, if I don't do anything, the number of passengers I'm going to fly is going to be 8,000. I'm going to make 8,000 times $100 per passenger, and I'm in good shape. But I want to know how this number changes, or if this number changes for each dollar increase in the ticket price. Can we figure that out? Do we have enough information to figure that out, or is that beyond the scope here? Sometimes we're asked questions and the real answer is, we don't have enough information to figure that out. We need more information. And then we go back to the polls and we say, what else do we need to know? And we need to know what day the flight is, or what the weather is, or what month it is, or whatever it is. So the idea is, can we come up with this number of passengers as a function of the ticket price, given the information shown here? And if we can, then let's come up with our equation. And I'll let you think about that for a bit. Maybe we can have a new volunteer provide us some help as we go through this problem. And if we don't have a solution, we can at least maybe have an approach that we could take to figure this out. I'll just record the time here just to see. One of the things that I'd like you to get used to when you're doing class problems or homework problems is about how long it's taking you to complete each problem, so that when you come to a test, you'll know about how much time you have on the test per problem, because you know the amount of time and the number of problems. And hopefully, if you've been successful in working all your homework problems, then you'll know that, hey, I've seen a problem like this before and it took me 3 minutes or 8 minutes or whatever the number was. And so that's how much time I need to allocate. So if you see a problem like this on a test, you want to kind of say, well, I know this took me about however long you think it's going to take you.
So I was thinking, would it be 8,000 minus 100x?
8,000 minus 100x. Well, it could be. Anybody agree or disagree? Now,
I don't
anytime,
agree, because the pass is $100 and X is also the ticket price. So you're just saying ticket price times ticket price by saying 100x. So
okay, so if the ticket price were $100 and each passenger pays $100, so this says it'd be 8,000 minus 100 times 100.
minus 10,000.
So we're losing money.
That's why I'm just saying that equation doesn't happen to work in this case.
Okay, so if this were true, it looks like we'd be losing a couple $1,000 if we set it up like this. And no matter what X is here, well, if X is 100, that's the ticket price. So if we lower the ticket price, well, it says for each dollar increase in the ticket price, we're going to lose 100. So do we think this is going to work, or do we think we need another solution here? And if so, what kind of a solution would you propose? I'll put
Can
a
we
question.
use another variable for the number of passengers?
Sure, you can do whatever you want. You just tell me what to write.
I'm still working on an overall equation, but I would want to use P for passengers.
So you want P over on the right-hand side or the left-hand side?
I'm still working on it.
Okay,
Sorry, I'll come back with a better answer.
okay, all right. And let's have some other volunteers as well, so that we get some practice doing these problems together. Somehow it looks like we're going to have to factor in this $1 for each dollar increase in the ticket price. And the ticket price is X. So for each dollar increase, we end up losing. So somehow we have to subtract 100 passengers for each dollar increase. Anybody help me out here?
What I've got so far, Professor, I guess instead of having n as a function of x, I've got 100 plus x equals 8,000 minus 100x.
100, go ahead and give me that again. 100 plus X?
Plus x
Yes.
equals 8,000 minus 100x. And that says that the ticket price of $100 plus however much you increase it by, you have to set equal to a total number of 8,000 passengers minus 100 of them for every dollar that you're raising it by, which is still X. So X is both the increase in your ticket price and the number of, yeah, you're losing 100 passengers for every dollar. I'm rambling.
So is this X1, or for if this goes up by X and X is $1, so if X equals 101 equals 8,000 minus 100.
Correct. And that should give you the value, the ticket price. Or well, you know that the ticket price is $101, but that should tell you how many total passengers you flew at that
Oh.
ticket price.
So 8,000 minus 100. So we're gonna 7,900. Okay. All right. So
This is why I think we need another variable, Professor. So I
Oh, okay.
didn't feel like it was good to have just the X in there. Am I
Okay.
even on the right track? I don't want to waste people's time here. Like,
Well, we're just
That's a
trying to
little bit of
we're just trying to work our way through this. We were asked to find the number of passengers. Keep in mind what we're asked to find. The number of passengers as a function of the price. So here's the number of passengers as a function of the price. So this is what we're asked to find. And we're saying, well, the number of passengers, well, it's going to be 8,000. That's what it started out as. But that's going to change. For each dollar increase, it's going to go down by 100 passengers for each dollar increase. So this says if we increase by $1, then we'll be down to 7,900.
so is it as simple as instead of having 100 plus X, it could be 100 plus N as a function of X on the left side of the equation?
100
That-
plus n sub x like that. So on the left side, we want n as a function of x equals this.
I'm just trying to find a way so that we can get a variable
Right,
that will, equal the
Right.
number of passengers. So
right. So if we had 100 plus
I don't think it
n
works either.
as a function of x, and then we put the 100 on the other side, because we're trying to solve for n as a function of x equals 8,000. Over here, we had minus 100. Over here, we want to bring this to the other side. So that's minus another 100.
It doesn't work that way, no, unfortunately.
Well, we need an x on the right-hand side somewhere, don't we? Because this is n as a function of x, the ticket price. So on the right-hand side over here, this looks good. We're losing 100.
Right.
This
I
is
was
good.
when I said to sub in the N as a function of X, I was actually referring to 2 steps above where you're working at right now, where we have 100 plus N as a function of X equals 8,000 minus 100 X.
All right. So
But I guess it doesn't really.
well, I think we're on the right track here. N is a function of, we start out 8,000. We want to subtract 100 per what? Per every dollar increase over 100. That's what we're trying to do. So this is a good starting point right here. I like this. I don't know that we need this because we're asked to solve for this. So the number is going to be 8,000 minus, we're going to lose 100 per something to do with X. And it's not just X. The ticket price, if the ticket price is as it increases over
So
100.
X plus 1. So Gopal was on the right track. I apologize. I'm pretty sure it was Gopal who said that earlier, who gave you the original equation. It just needed to be X plus 1 instead of X.
Yeah, let's just
Okay.
let's clean this up a little bit. So we're gonna change this to n as a function of x equals 8,000 minus 100. We're gonna lose 100 as every time x does something. As every time x is above the ticket price, which is what's the ticket price? 100. So every time x is above 100.
Oh, so minus 100.
Minus 100. Let's try that. So now if x is above 100 by, say, 101, 101 minus 100 is 1 times 100. And we subtract that from that. That looks like that would work, wouldn't it? Let's try other values and see if we think that would work. Starting out with 8, and we're subtracting 100 passengers for every dollar that the ticket price, which is this X, is greater than 100. So if the ticket price for 102 we would lose 2 passengers. We'd be $2 above. 2 times 100, we'd lose 200 passengers. If it's 101, we'd lose one passenger. 105, it's 5 above, we'd lose 500 passengers. That sound like it's working?
Yeah,
It does, doesn't it?
at least to me.
I think it does. I think it does. So we're starting out with 8,000 and we subtract 100 passengers for every dollar that X is greater than 100. Make sense? That looks good. Okay, questions on that at all, anybody? This looks good. All right, let's go to a new problem. If there are no questions, we'll go to a new problem. A machine produces boxes using metal sheets that are the size of 15 by 8. So let's say this is a rectangle that is 15 inches in this direction and 8 inches in this direction. And it produces open boxes by using a metal sheet that starts out this size, and then it cuts equal size squares from each corner. So it's going to cut a square from each corner. Here's a square, and here's a square, and here's a square, and here's a square. And it's going to cut this out of each corner. These are all the same size. And then it shapes the metal box into an open box by turning up the parts that are sticking out here. So I'm going to put a dotted line right here and say that gets folded up. And so each of these areas here are folded upwards so that we have a container we have this missing, those are all taken out, and we fold along those dotted lines. That makes sense? And the idea is we want to find the volume of the box. So I'm going to say find volume, and let's just call it V, in cubic inches. In cubic inches, because these dimensions are in inches, as a function of the size of the cut. So as the function of the, let's say the side of the square cut from each corner. Now we don't know what this size is. Since we don't know what it is, let's just call it X. So that's X, and each of these, the length of each of these sides is the same for each corner. We don't know what it is, but we're going to cut that out. And the idea is, can we somehow determine the volume, find the volume V of this box in cubic inches as a function of the side of the square cut? So let's just say as a function of, instead of the side of the square, let's just say as a function of X, which is the side, which is the square cut from the corner. So we'll call this X. So we want the volume when we turn up these edges here. And that's going to be length times width times height, isn't it? The volume equals length times width times height. That's going to give us a volume of what that box would carry, whether it's dirt or sand or water or whatever we're going to put in there. That would be the volume. So what we're asked to do is find V as a function of X. on something that looks like this. Now we know the volume is this times this. And we know that the length here is 15 and the length here is 8. So this length here is this length here, isn't it? That goes from there to there. And this width here is this width that goes along here. And then the height is going to be this x value, isn't it? Because that's going to be an x and that's going to be an x. So the height is going to be the x value. Okay.
The equation I wrote down was
Yes.
x times in parentheses 15 minus 2x close parentheses times 8 minus 2x and then end of parentheses.
Okay. Anything else? Is that it or?
Yeah, that's what I wrote down.
Okay, so let's say there's an offering here. And let's see if we can figure this out. X, which is the height. So we're going to say that's the height. And 15 minus 2x. So here's 15. That's the length minus this x minus this x. So we're going to call that the length value here. And then the width, this value here is going to be 8 minus 1x minus 2x. So did everybody agree that that looks like it would work?
I agree.
Okay. Everybody agree?
Yes, agree.
Good. All right. That looks good to me too. I have 4 o'clock. Let's take our, can we take a 5-minute break? Will that work for everybody?
Yes.
Okay. We'll see you in 5. Good work, everybody. Are we ready to resume? Is that a yes? Did I hear a yes? I don't hear a yes.
Oh, yeah.
Good. All right, let's see here. We've got a little bit of time. I want to spend some time doing review for the test as well. So I don't want to go too much longer, but let's see if there's any other problems that I might have for you. Well, let's say we have a rectangle and you have 200, let's say, feet of a fencing to go around this rectangle, whether it's a garden or a yard or whatever it is. And what we want to do is express the area of this, let's call it a garden. And here are our diagonal rows of carrots and tomatoes and whatever. And we want to express the area as a function of one of its dimensions. So if this is length and that's width, well, the area is equal to length times width, isn't it?
Yes.
And if that's true, and I know that I have 200 feet of fencing that, now let's just say that's a perimeter. Let's just say 200 feet is the perimeter. And I want to express the area of the garden as a function of one of its dimensions. And I know that the perimeter is 200. Do I have enough information to do that? Area equals length times width. Let's say perimeter. Perimeter is one length plus one width plus another length plus another width. So that's what, 2L plus 2W? That sound right?
Yep.
And that's going to be 200. And I want to, what do I want to do? I want to express the area as a function of one of its dimensions. So this is a function of two dimensions. I want to express it as one dimension. And let's say I want to express it as a function of the width. Is there a way we can convert any of the equations we have and just show width? Well, let's see, we have an equation here. If we were to solve this equation for L and then plug that L into here, that would do it, wouldn't it? So can we solve this equation for L? What do we get when we solve that equation for L? L equals what? So that's what I'm going to ask you to do. Solve this equation right here for L. 2L plus 2W equals 200. Or L equals what?
$100 minus W.
100 minus W. Everybody agree? Anybody disagree?
Yes, divide by 2.
I agree.
The lady that was talking, you want to divide this by 2? Is that what you said you want to do?
I think we can cancel the, oh wait, this is 2L plus 2W, right?
That's up here, yes.
Yes, so that would be L equal 100 minus 2W.
Minus 2W.
Yes, because there's a 2 in front of W.
All right, everybody
Sorry,
agree?
okay.
We had 200 before, so this L equals 100 minus W is already, we've already done the division of 2, okay? So Maybe we take it a step back, Professor. 2L equals 200 minus 2W.
So if we just take this equation and divide it by 2, we would get L equals, or L plus W equals 200, no, 100. This says L plus W equals 100. Now we want to solve it for L. So L equals 100 and move the W to the other side.
Oh, right. Right. Yeah, got
Alright.
it. Thank you.
All right, everybody agree? So we're done? We just put an arrow to here and say that's our answer? Is that what we were asked to find? What were we asked to find?
Area. I think we can plug in the L.
Yes, we were asked to find area as a function of W. So A equals L, and L equals 100 minus W times W. So that would be 100 W minus W squared, wouldn't it? Okay, does that make sense to everybody? So if that's the area as a function of W, we could, it seems like to me, we could plug that into our calculator, make that a function, and see what that would look like. Do we have any idea what this function would look like? Look like an inverted parabola? Looks somehow like that, which means that we might have some max here at this point. With some W, we're going to have some max area. So if we were to plug this into our calculator, we ought to be able to find the value of W that would maximize this equation, wouldn't we? Sound right?
Absolutely.
All right. So I'm not going to ask us to do that, but we know that we could. So we could say, well, if I want to maximize the area of this garden area, my width would be this value right here. All right, if that were our goal. All right, good.
I have a quick question here with this problem.
I'm sorry, what's the question?
So you asked to solve for the function of W. That means we had to plug in the length.
Well, yes, I asked for area as a function of W. So we have to somehow convert this L value into it being a function of W, which we did here.
Okay.
We ended up at 2L plus 2W was 200. Solve this for L, and we got L was 100 minus W. And then we plug that L value into here, and 100 minus W, that quantity times W gave us this quadratic, which we can look at this and say, this is a parabola. This negative says it's opening downward. So it's going to look like that, which means it's going to have a max out here somewhere. And that max is going to tell us what's the maximum area. That may not be what the question is, but if we wanted to find the maximum area, we could. There may be other restrictions on what the size of the length and width of this garden are. But if we said, hey, we want to maximize the area here, what's the width going to be? We could do that.
Okay. Thank you.
Okay. Let's see. What would be another here? You have, we'll do one more problem and then we'll do a little bit of review for the test, although the best review for your test is just make sure you do your homework problems. Let's say you have $25,000 that you're going to invest into 2 investments. And one investment pays 7% interest and the other pays 9% interest. And what I would like to find is, can we express the interest earned on this 25,000, which is invested here and here? Can we say that as a function of, let's say what, the amount invested? Let's say we have X invested at 7% and Y this amount at 7%, this amount at 9%, total amount is this amount. And I want to find the amount of interest as a function of the amount invested at 7%. Do I have enough information to do that? Let's see. I know that this amount plus this amount, the amount invested here plus the amount invested here has got to be 25, doesn't it? So we know, let's say, we have two unknowns. So in order to figure this out, we're probably going to need two equations, but let's see here. So X plus Y, the amount invested here and the amount invested here has to be 25, doesn't it? And then we need a second equation. And the second equation might be if we invest 7% and we represent 7% as 0.07, don't we? X, so this amount invested at 7% plus this amount invested at 9% is going to give me the total interest. So if the question were, what's the equation for the interest that you're going to earn on both accounts, you would say, well, the equation would look like this. Right, the interest as a function of X. Well, this is interest on both. So this is going to be total interest, isn't it? Not X, but total. The amount invested at 7% plus the amount invested at 9% is the total interest.
Is that a plus minus next to the total, or
This right here,
no, next to that on the right? Yeah.
that's I, interest.
Oh, okay.
That's this value here. Amount interest. So interest from X is going to be this much. Interest from Y is going to be this much, and the total interest is going to be this much. So do we have enough information then to figure out, let's see, what can we figure out here? Well, say we want to figure out total interest as a function of X. Yeah, let's say we want to figure this out. We want to figure out total interest as a function of X. That means we're going to have to do something with this Y value, don't we? And we can solve for Y from first equation, can't we? And if we solve the first equation for Y, it's 0.07 times X plus 0.09 times Y. Well, X is an amount of money. Y is 25,000 minus X, isn't it? Whatever, if I'm going to solve for Y, it's this 25 minus the X. So that's going to be 25,000 minus X. And that's going to give me the interest now as a function of X. There are no other values except X in here now. Okay. So then can we simplify this? And if we can, let's go ahead and simplify this. Tell me what you get when you simplify this and you solve for I as a function of X equals 0.07X plus 0.09 times 25 and then minus 09X. So we just have to figure out this value here, 0.09 times 25. What's that going to be? 0.09 times 25,000. Looks like that's 2250. So we just have to do some simplifying here, don't we? 2250, and that's dollars. And then we have 0.07 and negative 0.02. So 0.07 from 0.09 is negative 0.02X. So it looks like the interest as a function of just X is 2250 minus X. That makes sense. questions on that at all? Okay, let's see. Do I need to go over anything else? Let's see. Well, here's one more that's kind of interesting. I think you might enjoy. We have a cylinder, looks like this. And it has a volume of 1,000 cubic centimeters.
Professor, I can't see your paper. Will you mind splitting it?
Okay, and what we're asked to find, given that we have this, we don't know what this height is. It's going to be some height, and it's going to be some radius, whatever that is. So here's a cylinder with this radius and this height. And we know the volume of this thing is 1,000. And I'm going to ask you to find the surface area. So I'm going to say find surface area of the cylinder. I'll just say here's the cylinder. Find the surface area of that cylinder as a function of R. Surface area of the cylinder is a function of R. Meaning that, hey, we want to get rid of this H. We want to just call this R. So let's see, surface area. The entire surface area would include the top surface and the bottom surface and the side, this stuff here. So do we know the equation for the surface area of the bottom of this cylinder? Let's just say area B, the area of the bottom of that cylinder. You want that? What do we know what that would be? It's a circle, right? What's the area of a circle? What's the equation for the area of a circle?
Pi r squared.
Pi r squared. And how about the top up here then?
Going to be the same value.
Pi r squared. Okay. So the surface area is going to be pi r squared plus pi r squared. So it's going to be 2 pi r squared plus the surface area of the side. And what's the surface area of the side? That's if we cut this and laid it out flat, it would sort of look like this, wouldn't it? Where this is H. And this, how about this distance here? What would that be? What would be the formula for this distance? Be the formula for the circumference of a circle. What would that be? Circumference of a circle is what?
2 pi times the radius.
2 pi r. Okay. So it looks like then the surface area equals 2 pi r squared plus 2 pi r, which is this length, times the height. Here's the height. But we want to express it only in terms of r. We don't want this h. So somehow we have to convert this h as a function of r. Is there some way we can convert this h to some function of r? We're given the volume. And the volume, if we looked at the equation for the volume, that's the base times height, isn't it? Where base is pi r squared, that's this. Then height is this value. And we know that's equal to 1,000. So we can solve this for h, can't we? And we get h equals 1,000 divided by pi r squared, right? Which we can substitute here. So the surface area as a function of r is 2 pi r squared plus 2 pi r h, and h as a function of r is 1000 over pi r squared. All right, so it looks like that would do it. And I know many of you'd be tempted to stop right there, but we always have to simplify, don't we? So surface area equals 2 pi r squared plus, let's see, that pi will cancel that pi, and that r will cancel a square. 2 times 1,000 is 2,000 over what's remaining there, I guess, just r. So is there any further simplification we can do here, or does that look like that's it? Anything further we can do here?
Looks good to me, Professor.
Anybody else?
Can we factor out the 2?
Factor out the 2. All right, so you'd want to say 2 times pi r square plus 1,000 like this.
Maybe we can factor out 2r.
Factor out 2r. And if you take out the r from here, and what do we take out of here on this side? Can we take out the r on this value here as well?
No.
No? This is in the numerator, isn't it? That's over 1. This is in the denominator. Can't take out an r. We could take out a 2. 2 times pi r squared plus 1,000. Yes, we could do that. Can we simplify any further? So we might end up there. We might end up there. Anything else we could do?
I think that's it.
Okay. All right, so it looks like either of these would be acceptable answers. We wouldn't have to necessarily put that 1 in there. We could just say it's 2 pi r squared plus 2,000 over r and leave it that way. Or we could factor out a 2. That would work. Okay, good. All right, that's good. And let's see here. What do I have here? Last problem, and then we'll take a look at a little bit of some tests. If I have, if I give you the function y equals some function of x, let's see here. I don't have any more paper here that works a little better. Y equals some function of x equals x cubed. And if I were to graph that, and I say, well, I'm only going to look at positive values of x, and here's y, and this is a right angle, of course. And if I were to graph this, let's see, 1, 2, 3, and if I call this, let's see, 3 and 20, so 5, 10, 15, 20, 25. And this we call 0, 1, 2, 3. See if we can make a somewhat of a graph here. So if I create a table of value, here's x cubed. And I go 0, 1, 2, 3. 0 is 0, that's here. 1 is 1. That's there. 2 cubed, that's 8, isn't it? 3 cubed is 27. So 2 cubed is 8, that's there. 3 cubed is 27, which I'm going to say is there. So then I label my points, 3 and 27, because these points don't have any meaning if I don't put labels on them. 2 and 8. And showing the values over here is not the same as labeling the points here. I always want to see the points on the graph. And then 0, 0. If I were to connect those, it would look roughly like that. And it continues. And if I say, okay, if I say X, Y is some point on this curve, maybe this is the point X, Y right here. And I want to find the distance from P, this point P, to the origin, which is here. So I'm looking for that distance there. Now if I call that D, can I express that distance as a function of X? So I'm looking at D as a function of X. Is there some way I can determine that? So this gets back to the 2 points in an XY coordinate plane and how I find the distance. And this distance is the hypotenuse of a right triangle, isn't it? Where the right triangle is here. Guess maybe I should just do it this way. Here's the right triangle. And that distance, well, that distance I can say is a function of X, or I can just say the distance is this distance here. Well, I know Pythagorean theorem says that a squared plus b squared equals c squared, doesn't it? So if this is a, this distance, that's X. I guess d squared equals x squared plus, call this vertical distance y squared. So if I'm looking for d, I'd say d equals the positive root of x squared plus y squared. But if I want to express it only as a function of x, as I indicated earlier, so let's say I want d as a function of x only, then I need to convert this to an x value. Do I have enough information to do that? X squared plus, is there some way I can convert this value here to x? Is that information here?
Isn't the y value the like isn't the y value x values raised to the third power?
Up here. This up here?
Yeah.
Okay. All right. So we say x to the third power then, like that.
X to the third power raised to the second power because we're doing a y squared.
So we want to square this term here.
Yeah.
So d is a function of x equals the root of x squared. And then can I simplify this? Can this be simplified, or is that the simplified form?
X to the sixth power.
X to the 6, okay. And then can I combine these guys here? Can these be simplified?
X to the 8th.
So that looks like root x, like that. I'll just put a question mark there until everybody agrees. Everybody agree? X to the 2 plus x to the 6 is x to the 8. Is that correct?
Yes.
So we have one says yes. Anybody else? Well, I could plug in a value here and see if that's true. Let's plug in 2. Let's see if I said 2 squared plus 2 to the 6th equals 2 to the 8th. 2 squared is 4. 2 to the 6th, 2, 4, 8, 16, 32, that's 64. So on the left side, I have 68. And we're looking for 2 to the 8, 2, 4, 8, 16, 32, 64, 128, 256. So 2 to the 8th is 256. 2 to the 6 is 64. 2 to the square is 4. 64 and 4 is 68. So are those equal?
Oh, wrong.
So can we say 2 to the 6th plus 2 to the 2nd is 2 to the 8th?
No.
No, we cannot. All right, so that isn't true. So is there any further then that we can simplify this root here? Anybody? Can we simplify this any further, or is that it? That's it, isn't it? Because this is apples and this is oranges, and we're not going to combine those. Okay. How's everybody doing? All right, let's see. I think I've covered what I need to cover here. Let's see, that one, that one, that one. Yes, I think we've done all that. All right, let's just spend a few minutes then, maybe doing some summary work here on what kind of stuff have we covered. Let's see. If I ask you, if I said you have 1.2 times, no, that's not the one I want. That's not what I want. Where's the one I want? This one. We don't want that one. Let's say we're given a y value is 2 more than y value is 2 more than the square of the x value. Can you express this as an equation? Find equation and graph. Would you be able to do that? What would that equation look like? Anybody?
Wouldn't the equation be y equals x squared plus 2?
Y equals 2 more than the square plus 2. It'd look like that, wouldn't it?
Yeah.
Okay, everybody agree? Anybody disagree?
I agree.
All right, good. Say I give you 2 functions. Say I give you f of x and let's see here. Okay, let's say f of x equals -4 and g of x equals 4. That's what you're given. And you're asked to create a table of values for x f of x, g of x, from x going from -2, -1, 0, +1, +2. You're asked to create the table of values and graph. Can you do that? And we want to graph this thing here like this, x, y, and here's the origin at 0. So here's -2, here's +2. All right, can we create a table of values and then plot the points and then connect the points and graph it?
Yeah, so for f of x, the y value is always going to be -1.
So right here,
Yeah.
okay,
And for g of x, the y value is always going to be 4.
okay. All right, so for -1, so somewhere along here. And so we're going to have points here, and here, and here, and here, and here. -1 and -1, or -2, -1, -1, -1, 0, -1, 1, -1, and 2, -1. Okay, so those are those points. And we'll connect those points. There they are. And then for G, it's 4, 2, 3, 4. We have points up here like this. And on here, you can't tell where anything is, but you know where it is because I'm going to tell you that it's at -2 and 4, -1 and 4, 0 and 4, 1 and 4, 2 and 4. These points only have meaning because I've given you the actual location. So the lesson learned there is that you always want to show what the location of the points are in an XY coordinate plane. Don't just scribble out something and say, those are the points. This doesn't do it. We want to label the points. Okay. So have we answered the question? Have we done everything we were asked to do? Select the integers between -2 and 2 for x, create a table of values, and then graph. So we're going to plot the points and then graph. It looks something like that. So we need to connect that. And just so you can see it better, I will just put that across there and that across there. Okay, makes sense? Questions? Okay. If I give you, you remember the term piecewise function? Remember how that works? If I say f of x equals some value if x is, say, less than or equal to -1, maybe it's 4, and maybe it's -4 if x is greater than -1. Could we graph that? And we'd want to create a table of values, wouldn't we? And could we come up with a domain for that function?
Oh, what does that word say next to function?
Piecewise function?
Oh, okay, thank you.
So if we were to graph this and create a table of values, we'd want to show x and f of x. And if we're asked to do it less than -1, well, we might be what? -2, -1, 0, and greater than -1. So we might want to go out here at +1, +2. And when we go out here, if we're less than or equal to -1, we're at 4. And if we're greater than -1, we're at -4. So we've created a table of values. And the idea here is we set up our XY coordinate plane, and we're going to have to somehow indicate where these, so here's -2, here's +2, and -1, -2, and we're up at 4. So let's say that's 4, and let's say that's -4. And at -2, I'm at 4. -1, I'm at 4. 0, I'm at -4. 1, I'm at -4. And 2, I'm at -4. And we're asked to graph that. X is less than or equal to -1. So here's -1. So it looks like it's going to go that direction. If it's less than or equal to -1, there's -1. And if it's the other, we're down here, so it looks like it's that direction. Is that what we need? Is that it? The idea here is we're trying to say if this is less than or equal to -1 and it's 4, then we're going to have to indicate that some here. We're either going to have to put a bracket here that says this point is included, or color that circle in all the way that indicates it's included. But somehow we have to indicate that that's where it starts. It's a piecewise function. It's different values. Down here, if it's greater than or equal to -1. Well, here's -1 here. So it doesn't start here, does it? It starts back here. But it doesn't include the -1, does it? Greater than or equal to -1. So it's just greater than -1. So here, this would be open, or could be a left paren, couldn't it? Whatever way you want to indicate it. So they both start at -1, but here we include the -1. Here we don't include the -1. That makes sense to everybody? What's going on there? You have to make sure you get these values correct. If you're talking about less than or equal to, greater than or equal to, we want to make sure that we show that it's a circle. And if we're including, if we're saying less than or greater than equal to, and it's going to be open or using parentheses if it's just less than or greater than. Okay, and we can see here that at this point, we have to show the proper notation here.
So we don't need to show both, right? So we only need to show either the circle or the brackets.
You either need to show the solid and or a bracket. This is an or situation. And then down here, it's either an open circle or a parenthesis. This or this, this or this.
Okay.
So you could show bracket and a paren, or you could show a closed circle and an open circle, where the values you're talking about are here and here. But we don't include this value. And this right paren says we don't include that value. We go up as close as we can get to it, but we never include it. Same way here. These are just two ways of showing the same thing. This is inclusive, whether it's a bracket or an enclosed circle. I think that's not new to this class. You learned that back in 97, 98, 99, haven't you? Okay, let's see. If we have some other examples we might go through here. Domains. You might get something that looks like this. Maybe you get 6x minus 5f of x minus 20 equals 0. And you're asked to graph from x equals whatever, minus 2 to plus 2, or whatever the values are. You might be asked to graph that from certain values. Would you be able to do that? Go ahead and give that a try and see if we agree on what that should look like. So this is what we're given. And we're going to want to graph it on the XY coordinate plane from, let's say, -2 to +2. This looks like it's a line or a curve or a parabola. What do we think this looks like? Anybody know what that looks like?
Is it a line?
If it looks like a line, then it must look like y equals mx plus b. So if that's true, we have to find a value for m and a value for b, don't we? What do we think? New volunteer? Can we solve this equation? How would we solve that? 6x minus 5, and what is this f of x? What is that thing?
Could you just substitute the f of x for y?
So we could say y equals f of x. So we could say that's y minus 20 equals 0. Can we solve this equation for y?
Wait, so f of x turns into y in that equation? Is that how it works?
Well, remember when we're setting up our equations of a line and we say y equals some function of x equals 6 over 5x minus 4, for instance.
Oh yeah.
Remember that?
Okay, yeah.
Okay, so if that's the case, go ahead. Question?
I'm a little bit confused about the top part where it says 6x minus 5 f of x. Wait, is f of x like in the equation? So it's 6x minus 5 times x f of x minus 20 equals 0?
That's true.
Okay, so you're multiplying it. 5,
Yes,
negative
yes,
5.
that's true.
Okay, sorry, I was just a little confused. Thank
That's
you.
fine. And remember, we substituted y for f of x. As shown here, y equals f of x equals, and here's the function. So y is the dependent variable. X is the independent variable. Here's the slope. Here's the intercept. We've just written it in a different form. So if I change the form, I could say 6x minus 5, and in place of x, I'll just write y. I don't have to, but I could write y just so it looks a little more familiar. Minus 20, and then solve for f of x or solve for y. So I left the 6x, left the 20, brought 5y to the other side. Divided through by 5 because I want to solve for y. So now I get 6 over 5x minus 20 over 5 is 4. So now I end up with y equals 6 over 5x minus 4. A little friendlier. So now if I say what's the slope, m equals this value here, isn't it? 6 over 5. And the intercept, b, is negative 4. So I'll go down here, 1, 2, 3, 4. And that's the intercept. So that's it, 0, negative 4. And I have a slope that's just a little greater than 1, isn't it? If it were 5 over 5, the slope would be 1. It's a little more than that. So if I go out 5 units, then I'd have 6 times 5 over 5, or I just have 6 minus 4, that's 2. So if I got 1, 2, 3, 4, 5, and I'm up 2. So it looks like I'm here at 5 and 2, if my arithmetic is correct. And so it looks like we'd have a line that does that. So if we're saying graph this thing, you know, I could put arrows on there saying it continues to go. And I have a point at 2 and 5, which is located here. And I have a point at 0 and negative 4, which is here. And I connect those 2 points, and I should have a line that does that. Okay, questions? Okay. Let's see. If we're looking at y equals some function of x equals double vertical line, that means absolute value, doesn't it? Which is ABS. If we look on our calculator under the catalog, we could find an absolute value function. And what does that tell us about what y is going to be here? If x is positive or negative, what's y going to be?
Positive?
It's always going to be positive, isn't it? We only want the magnitude. We don't care about the direction. So if we set up a table of values and have x and absolute value of x, and I go from -2. So if x is 0, what's y going to be? New volunteer? Any new volunteers can help us out?
0.
0. If x is -2
2,
and +2.
2,
Okay, so if we were to plot this thing, 1, 2, 1, 2, 1, 2, so it looks like it's going to be here and here and here and here and here. So it looks like we're going to have something that looks like that. And then we say that's 2 and 2, 1 and 1, -1 and 1, and -2 and 1, and -2 and 2. And so if anybody were to say, what are those, where are these points here? They're at -2 and 2. And that's a 2 and that's a 1. -1 and 1, 0 and 0, +1 and 1, +2 and 2. So we've got a graph on the XY coordinate plane that's completely labeled. We've got our points plotted. We have our table of values. We've connected the dots shown with the arrows on the end that it continues. Say, hey, that's great. You say, well, given that we have this, how about you graph h of x, which looks like absolute value of x plus 3 minus 2. Graph that. Now, what is that going to look like? -2, so it looks like we're going to come down here 2. Let's set up another table of values then. X and x plus 3, -2, -1, 0, 1, 2. X is 0. We get absolute value of 3, which is 3. Minus 2 is what?
1.
1. Okay, let's say x is -3. So I'm going to change this to -3 here. If I said x to -3, this becomes 0, and h of x becomes -2. If I say x is +2, this is 5 minus 2, that's 3, isn't it? That's a +3. If I say -1, -1, this is +2, minus 2, that's 0. +1 is 4, minus 2 is 2. So let's see if this graphs properly for us. So when x is -3, -1, -2, -3, we're at -2. So we're down here like that. -3, -2. -1, we're at 0. That's that. At 0, we're at 1. So that's there. So maybe I should mark these with a different color so I can see them a little better. So that's there, there, 0, I'm at 1. At 1, I'm at 2, so I'm up here. At 2, I'm at 3, so I'm up here. So I've got a line that goes like that, but it looks like I haven't gone farther enough to the left. I don't have any values over here. So let's put some more values in over here. Let's go -4, -5, -6. Let's see what we get here. 2, 3, 4, 5, 6. So let's see here at -4. Difference between that is that gives us a -1, but that becomes a +1. So that becomes a -1. Is that a -1 right there? Is that correct? Before I go on, if we're x is -4, what's y? And we said -2, so we're going to x plus 3 and then -2. So if x was 0, this is 3 minus 2 is 1. We agreed with that. Let's get my red pen out here. So if x is -4, 1, 2, 3, 4, and I put a -4 in here, the difference between -4 and 3 is 1, and we want a +1 and a -2, so that's going to be -1, isn't it? So over here, I'm at -1. So there's -1, so we're going up this way. And at 5, -5, the difference is 2, it's positive, so we're going to be at 0. That's there. And at 6, we're going to be 3. 6 will be 3 minus 2 is 1. So it looks like we're going to be up here. So we have a line going up this way. So what happened to this original curve that was absolute value of X? It was in pencil color here, black. Sitting here, the origin is at 0, 0. Where is the origin of the new curve? It's here, which is located at where? -3, -2. Now, the reason I want to emphasize this is we take a look at where the origin is moved to. Went from here to here. It shifted left 3. And yet I had X plus 3 in here, didn't I? So that the lesson learned here is that if this is X plus 3, it shifts left. Shift left. 3. 1, 2, 3. Shifts to here. And then this shifts down. Down 2. So we went left 1, 2, 3, and down 2. So just keep that in mind. This has a plus, but we're shifting left. And we proved it by creating this table of values. Okay. And the last one I want to take you through is this, where we have a combination where you might be given an f of x and a g of x. And I might say, what is f of g of x? And we can rewrite that in another form. We could say f of g of x. Okay, so just keep in mind then that we have the ability to, well, let's put in an example here. And we have combinations of functions. If I say f of x, and we'll make this the last example, 2x minus 5, and g of x is a 4x minus 1. And I say find g of f of x. And you'll say, well, the outer function is g. I could rewrite that if I wanted to, f of g, or g of f of x. So g is the outer function. So this is what I'm using. And I'm saying 4. And then instead of x, it's not g of x, it's g of f of x. And what's f of x? Well, that's this thing. So that becomes 2x minus 5. And then minus 1. So g of f of x looks like 4 times this quantity, which is 8x minus 20 minus 1, or 8x minus 21. Okay, so g of f of x would be determined that way. Questions on that at all? And then we might evaluate that at some location. Okay, so I might say find g of f of 2. Well, that's just evaluating at 2, isn't it? So we'd have 8 times 2 minus 21, which is 16 minus 21, which is negative what? 5. Okay, so we can use these combination functions, substituting, and then we could put in an actual value as well. Okay, good work, good review. That's all I have. So then tomorrow we'll have our chapter 1 test. It's a 60-minute test. So you'll have the first hour, and then after the first hour, submit your solutions, and then you're free to go. All right. Questions at all?
Wait, you said tomorrow?
No, he meant Monday.
Monday. Yeah, next class.
Oh, Monday. Okay, thanks.
Always the next class. Okay, so we reviewed today, and our next class is on the 1st, which is a Monday. And we'll have a 1-hour quiz, and we'll take it during the first hour. And then you're free the rest of the day.
Thank you.
All right, everybody, good work. See you Monday.
Thank you.
Thank you. Bye.